Hello, Year 10. Today we are starting a new topic on functions, polynomials, and other graphs. Today's lesson is about functions specifically and their notation. So any set of ordered pairs that we can use to plot on a graph is called a relation. A relation in which each x value produces only one y value is called a function. And when we use function notation, instead of saying y equals, and maybe we have a straight line, which is y equals 2x plus 3, we can say f of x. So it's written like this, f bracket x close bracket, but when you read it, you say f of x, means a function of x. So in summary, anything that we can graph, anything at all, can be called a relation. But more specifically, there are certain types of things that are functions, which for every x value, there is only one y value. To know graphically if something is a function, it will pass the vertical line test. And that is, if you can draw a vertical line anywhere through that graph and it will only cut it once, then the graph is a function. And we'll be practicing that in a minute. Also, we have some new words here, which is domain and range. If we have an equation or a graph, we may be asked to find the domain, which is the possible x values that are allowed for that relation. And the range is the possible y values for that relation. Let's have a look at our examples. Example number 1. So it says for f of x equals x squared plus 8x minus 9. So it's using the function notation, the f of x. And I'm asked to find what f of 0 is. Now the 0 has taken the spot of the x. So that means we are simply going to substitute 0 in for x into our equation. So that will be 0 squared plus 8 times 0 minus 9. And that's equal to negative 9. So if I want to know what f of 3 is, now the x is equal to 3. And I substitute 3 into the right-hand side of my equation. 3 squared plus 8 times by 3 minus 9. That is equal to 24. F of minus 2 means that we're going to sub minus 2 into our equation for the x value. So it's minus 2 squared plus 8 times by minus 2 minus 9. Type that into your calculator and you will get negative 21. And one more of these, we want to know f of p. That means we are replacing the x values with a p. So that will simply be p squared plus 8p minus 9. And since we don't know what p is, that's it. That's all we can do. Question 2. From the following, identify which are functions. And this is relying on the dot point where we said a function has for every x value only one y value. So if you look through at these x values, we have 1, 2, 3, 4, 5. They're all going up nicely. And then the y values, 2, 4, 6, 8, they are also going up by 2s. There is no overlap. There is no point that has the same y value in it. So this is a function. Okay, part B, we have an equation instead of some points. And if you think back to some of our previous work, that graph would be a parabola. The intercepts of that parabola coming from this factorized form would be x equals 0 and x equals minus 2. So very roughly, I would have 0 and minus 2, and it would be a concave up parabola that looks like that. Now, if I were to draw a vertical line anywhere through that parabola, it would only ever cut it once, no matter where I draw it. So that means that this is a function. Question 3 is more specific about the vertical line test. It says, use the vertical line test to decide which of the following are functions. So we have to think in our head, and we can draw one or two on the page if you like. If I draw a vertical line going through that graph, is it only ever going to cut it once? If I try to be sneaky and draw it up here, it's still only going to cut it once. So that means that this one is a function. When I look at part B, as soon as I draw a vertical line through the middle, I'm cutting that parabola twice. So that means that this one is not a function. Question 4, write down the allowable values, which is for the x values is called the domain, and for the y values is called the range, for each of these functions. So, these first two that we have here are graphs that you should be able to draw relatively easily. Y equals 3x minus 2 is a straight line graph. And I'm only going to draw this roughly. You don't get marks for the graph. It's just so you have a rough idea of what it looks like. The y-intercept would be at -2, and a gradient of 3 means it's pretty steep. I'm not even going to count a rise and a run, but I have a steep line going through that y-intercept of -2. Now, I have drawn a relatively small graph, but if I wanted to, I could keep extending this line as far as I want to, which means for any x value that I come out down here or even further over, I'm always going to be able to find a y value. If I went to the negative side, the same thing. I could come way out to the negative numbers here, and I could keep extending my graph out and could find a value if we wanted to. So when we talk about the domain, because I can keep extending my graph as long as I wanted to in any direction for the x values, we call that all real x. All values of x are possible. I could sub in any value of x that I wanted, and I would be able to find a point on that graph. It also means that for every x value, there is going to be a y value that goes with it. So it is also all real y values as well. Looking at the second one, y equals 9 minus x squared, that is a parabola. The 9 is the y-intercept, somewhere up here, and the minus x squared means that this is a concave down parabola, something very roughly like that. Now again, if I think of what x values I could put into that equation, I could put any x value in, and my parabola would just keep going as far down as I wanted it to go. So my domain is still going to be all real x. The range this time is different. So the highest value on my y-axis that my parabola will ever get to is 9. It doesn't matter how many different x values I sub in, everything is going to be 9 or less. So that means my range is going to be y is always going to be less than or equal to the 9. It won't ever exist above that 9. Okay, so those are ones that you could do if you are able to draw the graph. On the next page, we have some that probably aren't graphs that we're very familiar with. So there's a couple of other strategies that we want to think about. The two things that we want to know about are square roots and fractions. If you have a square root, you can never square root a negative number. So that means that whatever is underneath that square root sign always has to be greater than or equal to 0, because it can never be negative. If I solve that little inequality, I would move the 2 across the other side, and it would tell me that x is always greater than or equal to 2. So that's my domain. The domain is that x is always greater than or equal to 2. Now what's happening to my y values, my range? if 2 is the smallest value that I could ever put into that square root, if I put 2 in there, I would get 2 take away 2, which is 0. So let's use our calculator for this as a little bit of a demonstration. Square root of 2 take away 2, and the smallest y value that I have there is 0. And x is going to be getting bigger from there. So let's say we went up to 6. And it's going to be getting bigger, or we go up to 10, or let's go even bigger, let's go up to 20. And the y values are going to start getting bigger. So the smallest value for y that we're ever going to be able to get was when y was equal to 2, which gave me 0. So my range is y is greater than or equal to 0. Okay, part D, the fractions. When you have a fraction, you can never divide. Whatever's on the bottom of that fraction can never be equal to 0 because you can never divide by 0. So whatever is there, the 2x minus 1 for this question cannot be, so it's the equal to with a line drawn through it because it cannot be equal to 0. So let's solve that. We're going to have 2x cannot be equal to 1, and dividing by the 2, x cannot be equal to half. So that's my domain. The domain is that x cannot be equal to 1/2. What about the range? For the range, I'm going to do a little rearrangement of my equation here. If I times the 2x minus 1 over to the other side of the equation, and then I get the 2x minus 1 by itself and divide the y back over to the other side. What happens there is that I now have y on the bottom of the fraction, which indicates to me that that y can never be equal to 0 because we know that we can never have 0 on the bottom of a fraction. So my range is y cannot be equal to 0. Question 5, back to some function notation, some slightly harder types. I'm giving you two functions. The first one is f of x equals x minus 2 all over 4. And the second one, just so we identify it as a different function, we're calling it g of x is equal to 2x squared minus 4x minus 5. Okay, so we are asked to find what f of 0 plus g of 0 is equal to. So I'm going to work out what those two things are over on the side first. If I want to know what f of 0 is, that means I need to sub 0 into the f of x function. So that's going to be 0 minus 2 over 4, which is equal to negative 1/2. Then, if I want to know what g of 0 is, then I sub 0 into my g of x equation. So that's 2 lots of 0 squared minus 4 lots of 0 minus 5. That is equal to negative 5. So f of 0 plus g of 0, f of 0 was negative 1/2, g of 0 was minus 5, so minus 1/2 minus 5 is minus 5.5. Part B, 5 lots of f of 2 minus 3 lots of g of 2. So again, on the side, let's work out what f of 2 is and then g of 2. So f of 2, subbing 2 where the x is, we're going to get 2 minus 2 over 4, which is equal to 0. Then g of 2 is going to be 2 lots of 2 squared minus 4 lots of 2 minus 5, which happens to be equal to minus 5 again. So if I want 5 lots of f of 2, I want 5 times 0 minus 3 lots of g of 2, which is 3 times minus 5. 5 times 0 is 0, minus 3 times minus 5 is a positive 15. Part C, f of 2a. So this is putting a 2a where the x is in the f of x equation. So I'm going to sub straight into this one, and it's going to be 2a for the x minus 2 all over 4. And I have done it, I have substituted in, but that can be simplified because everything in that can be divided by 2. So dividing each term by 2, I get 2 divided by 2 goes once, there and 4 divided by 2 goes twice. So my final answer is 1a, or a, take away 1 all over 2. Question D, final question. This is read as f of g of minus 2. Starting with the innermost bracket, I want to know what g of minus 2 is. So looking back at my g of x equation, that is 2 lots of minus 2 squared, and then minus 4 lots of minus 2 minus 5. Calculate that, and you get 11. So the g of minus 2 is equal to 11. So that means this is now f of 11. So now I want to sub the 11 into the f of x function. So that's going to be 11 minus 2 over 4. 11 minus 2 is 9. So 9 over 4, or 2 1/4. Okay, that's it for our first lesson. You now need to do exercise 10A.